So apart from naming, uh, scientists like to use chemical formula to represent the compounds. So that is easy to understand. Scientists are lazy. Or we can say all people are lazy. If I write carbon dioxide, okay, do an experiment. Okay, carbon dioxide, okay. So at least a couple of seconds to do it. If I but if I have formula, okay, CO2, that's it. So that is the functional formula. It makes the life simple. That makes scientists' life simple. So what? But we have different kind of formulas. You need to get used to what formula, what information, particular formula is giving to you. So for molecular formula, it is only for molecular substance, that is covalent substance. They do not use molecular formula to ionic compounds. So molecular formula is a formula which show the actual number of each kind of atoms in one molecule of the substance. Okay, so that is to tell you what atoms are involved in the compounds. Uh, that is the most simple molecule, most simple formula that you have. But sometimes if you just look at CO2, you would like to know more details about the bonding of the CO2. Okay, here from previous discussions, we know that C has a double bond with O. But if we just look at molecular formula, we do not have this piece of information. So that is why we have structural formula to show how the constituent atoms are joined up in one molecule of the substance. Using CO2 as an example, okay, I would draw it like this. Okay, that is what structural formula of CO2. You have two straight lines representing two bond pairs, two straight lines representing two bond pairs here. So that is easy. So let's look more examples. To know about the structural formula of the covalent substance, you must know the electron diagram of that substance so that you know whether single bond, double bond, or triple bond is formed. So usually the order of figuring out the structural formula is: first, you found the molecular formula, and then you draw the electron diagram, and then you find the structural formula. Alright, that is the usual order. So from previous discussion, we know that hydrogen is sharing one electron with another hydrogen, so that's why you have single bond. Oxygen, you have to share two electrons with another oxygen to become octet, so double bond. Nitrogen, you need three more electrons to become octet, so that's why it's triple bond. So that's how structural formula works. So first, you figure out the electron diagram of ammonia, 1N, 3H. So since 1N is forming single bond with another H, so we can draw N one straight line to represent the single covalent bond, another straight line for another hydrogen, another straight line for the hydrogen. So for the lone pair, it could be omitted in the structural formula, or sometimes you also see it with, to be drawn out. That is fine. You make it or do not make it. So for H2O, you draw the electron diagram out. Okay, it just looks like Mickey Mouse. That is the way I like to draw it. So you have one single covalent bond of O and H, another single covalent bond of O and H. So we use one single line to represent the single covalent bond, another single line to represent another single covalent bond. For CO2, I have discussed it before. It is double bond with the oxygen, another double bond with the oxygen. Okay, sometimes you may need to do it another way around. You are given the structural formula, and then you want to use a simpler way to represent it. So you want to figure out the molecular formula. So Well, I have 1H, 2H. I just write 2H here, and then 1S. So the molecular formula of the hydrogen sulfide is H2S. So for here, I have 1C, 4Cl, CCl4. Right. So here I have 1H, 2H, 1S, and 4 oxygen. So I have H2SO4. Right, some of you may query, how can I know the order of the elements we put in the molecular formula? Up to here, I do not have any information for you, but if you're interested, we can discuss during the lessons.